Okay, in this video, we're going to look at, we're going to work more with triangles. So we've already done some work with triangles back in section 5.2. So what we already know about the triangles is that if you have a right triangle, the Pythagorean theorem holds true. So the square, you can square each of the shorter sides and add them up, and that would equal the square of the long side. And then something else that we learned back in 5.2 was just the definitions for the basic trig functions, that sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. Now, the hypotenuse is always C, but which of the letters, little a or little b, turns out to be opposite or adjacent depends on their position relative to the given angle. So you just have to wait till you see the parts that you're given. All right, so what's going to happen in this next unit is we're going to be focused on triangles. The first section kind of extends what we already know, and we do several applications of right triangles. We've already done some, and this just does more. And then in the next two sections I like to do, I want to look at triangles that aren't right triangles. So we're going to wind up using something called the law of sines and the law of cosines to help us when our triangles don't have a right angle in them. Okay, so that's what's happening in the next unit. It kind of happens pretty quick, so you got to really stay caught up on this because there's really only 3 sections that we work through. So I just wanted to do some examples from 5.8 in this video. And so part of what they're going to ask us to do is to solve the right triangle. So what that really means is they want us to find all the missing pieces of it. So for instance, they might give you an angle, like angle A is 62.7 degrees, and the side opposite that is 8.4 centimeters. But then what they want you to do is find all of the missing pieces. So it's kind of like in your mind, I usually just think of it like this. Okay, the angles and then the sides opposite each of those angles. And so I know the 62.7 and I know the 8.4, okay? I know C is 90, and then I just need to find all the missing pieces. All right, so I can find the missing angle because I know all 3. That's something I should write up here. The angles in a triangle add up to be 180, don't they? 180 degrees. So we also know that to be true. So we can take the 180, take away 90. Notice you're in a right triangle, so you always know the 2 remaining angles have to add up to be 90. So you really can just take 90 and subtract the 62.7, and that would be 27. This right here would be 27.3 degrees. Okay, so that was something new that we were able to find. By the way, A and B are always complements of one another. They always add up to be 90 if we're in a right triangle. All right, so now what our job is to start finding what the lengths should be. So here's what you do for that. You look at the given information, and it's better practice to work with the given information. And you try to find a trig ratio that relates the angle A and the 8.4. Okay, and so if you look at that, the 8.4 is opposite angle A. So that means I might be able to use either sine or tangent to try to find C or B. So let's say we decided to go with the sine. We can see that the sine of 62.7 should be equal to the side opposite that angle divided by the hypotenuse, which is little c. Okay, so now we just need to work through the algebra of that. So I'm going to multiply both sides by c. Okay, and that gets me to here. Okay, so I multiplied by c on both sides, and that got me to here. Then I'm going to divide by the sine of the 62.7 degrees on both sides. Okay, all right, so I'm going to take the 8.4 divided by the sine of 62.7, and that gives me that C is about, and they said in the example that I was using in the book, they wanted the lengths rounded to 2 decimal places and the angles rounded to 1. So if I round to 2 decimal places, that'll be about 9.45. Okay. Now, ideally, you really shouldn't use things you've rounded and all, but you probably will get the same answer if you use the Pythagorean theorem now to find the missing side, or you could use a trig ratio to find the missing side so that you're not rounding. So what we could do is just go back now if we wanted to and do tangent of that same angle would equal 8.4, but over b. And so then b, tan of 62.7 degrees is 8.4. And just like before, we would divide. So I'm going to divide by the tangent of 62.7. All right, and also don't forget throughout this whole chapter, don't forget to check the mode that you're in. So you need to be sure that you're in degree mode for this. All right, so when I do that, I get that B turns out to be about 4.34. Okay, so B was 4.34, C was 9.45, and we did know the units, so we should include the units. That's a 5 right there. Okay, so that's what they mean by solving a right triangle. And like I said, there are different routes you could take. Like now that we know, once we figured out the 27.3, we could have done maybe tangent of 27.3 and done equals b over 8.4. That would have worked. Or we could have used the Pythagorean theorem to find the missing. Once we found one side, we could use the Pythagorean theorem to find the missing side. But since you rounded when you found that, that's not as good of a practice because you don't want to introduce round off error. Okay. All right, so let's look at another example. Okay, a lot of times they get into like descriptions. All right, so I'm using some examples that are coming out of section 5.8, and I'm doing what are called the checkpoints. So you can open those up if you'd like and read what the problems were. This one said, from a point on level ground 80 feet from the base of the Eiffel Tower, the angle of elevation is 85.4 degrees, and we're supposed to approximate the height of the Eiffel Tower to the nearest foot. Okay, so this is my Eiffel Tower right here. Okay, it said from a point on level ground 80 feet from the base of the tower, so the ground is level, and out here 80 feet away from the base of the Eiffel Tower, we know the angle of elevation. So that means if you were to sight up to the top of the tower, that this angle right here is 85.4 degrees. And then it asks us approximate the height of the Eiffel Tower to the nearest foot. So we want what this is, and we want to do it to the nearest foot. Okay. So we've done problems like this. Actually, you had it on the last test that you took. If you're looking at that picture and you're looking at the angle, 85.4, the 80 feet is adjacent to it. Here would be the right angle. So the 85.4 is adjacent, and what we want is opposite. So that would mean tangent would be the relationship we would use. So the tangent of 85.4 should be the side opposite over the adjacent. All right, and so this one's a little easier to solve than the earlier situation. Okay, so we wound up having x winding up equaling 80 times the tangent of 85.4 degrees. And we're already in degree mode, so we don't have to worry about that. So we'll just type in 80 tangent 85.4, and we get that x is about 944.306, blah, blah, blah. And they said nearest foot. So it's about 994. I wrote that wrong. It was 990, not 40, 994 feet tall. Okay. All right, so that's one where we had to draw a picture in order to figure it out. Okay, here's another one. These are just kind of common situations that you see. So this one is checkpoint 3. It says a guy wire, that's the wire that's used to support like telephone poles and that kind of thing. So it says a guy wire is 13.8 yards long and is attached from the ground to a pole 6.7 yards above the ground. Okay. All right, so that sounds interesting. So here's our pole. Okay, it's 6.7 yards. We have this wire going to the ground to support it, and it says the wire is 13.8 yards long. Okay. And it says find the angle to the nearest 1/10 of a degree that the wire makes with the ground. Okay, so you are kind of assuming that situation, and that would be a right angle, and we want to know what this angle is right here. So we are going to use something that we didn't use a whole lot in the previous chapter. We did a little bit with it, but not much. Okay, first, you're going to look at the picture. You're going to think about the relationship between the angle and the two lengths that you have. And you see how 6.7 is opposite the angle and 13.8 is the hypotenuse of the right triangle? So that would be a sine relationship. So you'll say the sine of theta equals the 6.7 divided by the 13.8. Right now, we didn't know the angle on this one. We're actually looking for the angle. And that's what the functions that you see on your calculator above sine, cosine, and tangent, that's what they're all about, okay? It's like the inverse of each of those, the inverse of the sine function. So those functions that look like this on your calculator are the ones you use when you need to reverse the process and figure out what the angle would be, okay? So here's the idea. We're going to come in and we're going to do sine inverse. It's like we're composing functions, but they just don't really get into the why of it that much, but that's what's really going on. We're going to compose, we're going to do sine inverse on both sides, okay? So whatever you do one side, you do the other. So we're going to apply that function to both sides. Okay, finally I got it. Okay, so sine inverse of sine of an angle, they undo each other, sort of. If you're in a triangle, you're safe because the angles are acute. Later, we'll have to be more careful about this. So we're going to wind up getting theta equals, and then to do sine inverse, you have to do second function, hit the second function key on your calculator to access those functions above the regular buttons, and then take 6.7 divided by 13.8 or enter it as a fraction. And again, make sure you're in degree mode because whatever mode you're in, that's what they'll give you back. So that tells us on our calculator, we see that the angle turns out to be about 29.0457 and has more going on. And that problem said to find the angle to the nearest 10th. So that would be 1 decimal place. So it'd be about 29 degrees. Okay. All right. Now, one more situation that they sometimes have you do that I want to cover in this video is sometimes you have more than one triangle within the problem. Okay, so this is checkpoint 4. All right, so it says you're standing on level ground 800 feet from Mount Rushmore, looking at the sculpture of Abraham Lincoln's face. Okay, so let's say here's the ground, and let's say here's the mountain. Okay, and so we're standing 800 feet from Mount Rushmore. So let's say we're standing right here. That would make this 800 feet. Okay, and these are not drawn to scale. I don't really know how tall Mount Rushmore is or anything like that. Then it says the angle of elevation to the bottom of the sculpture. So you're looking at the sculpture of Lincoln's face. So to the bottom of his face, to where his chin is. So let's say right here we have a person's face that we're looking at. That's terrible. You art people, oh my goodness, must be just dying. All right, so here we've got a face. Okay, and it says the angle of elevation to the bottom of the face. Okay, so to right at his chin is 32 degrees. So this is 32 degrees. And then I'm going to draw it in a different color. It says the angle of elevation to the top. So up to the top of it winds up being 35 degrees. Okay. And then the question is, find the height of the sculpture of Lincoln's face to the nearest tenth of a foot. So find out this right here. Okay. So what we're going to do is we're going to look at that all the way from the top to the ground. And then we're also going to look at this from the bottom to the ground. So think about those as two separate triangles we're going to explore. All right, so the right angle comes in right here. And it's a right angle in both this small triangle and the one that has the red hypotenuse, this guy here. It's also the right angle in that one. Okay, and they both use the 800, which is a side adjacent to these angles. And on both of them, we need a side opposite. So we're going to set up two things. We're going to say the tangent of 32 degrees equals, and let me call this A, equals A over 800. And then let me call the one that goes all the way from the top to the ground, let me call that B. Then tangent of 35 degrees, should do that in red, shouldn't I? I should color code it for you. Okay. All right, so let me do that one, should be there. Do that one in with a B. All right, then the tangent of 35 degrees would equal little b over 800. And so both of those are kind of the same setup, but here's the logic I'm going to use. So I'll be able to get little a and little b, and then do you see what I want? See that what I want is basically the difference between them. Okay, so this x right here that I want will really come from taking b and subtracting a. So if I can get the little a and little b, I can find the answer to the question. So I'm going to multiply both sides by 800 on both of them. Okay. Knocks out the 800. And so I have that a will equal 800 tangent of 32 degrees, and little b will equal 800 tangent 35 degrees. Okay. And then I just do each of those on my calculator. Make sure you're in degree mode. Your mode doesn't change unless you change it. So if you are working like a series of problems, you don't have to check on each one of those. Okay. So this A turns out to be about 499.8954, keeps on. And then B turns out to be about, let me go up there and just change that to a 35. Turns out to be about 560.166 and so on, okay? And then we're supposed to find the height of the sculpture to the nearest tenth of a foot, okay? All right, so normally I just keep quite a bit of accuracy on things and then I round at the end. So I'm going to take the 560 and maybe keep 2 decimal places of accuracy. So 560.17. Okay. And then I'm going to subtract from it the 499, and maybe that one, well, that one when I round to 2 decimal places turns into 0.90. So minus 499.90, and that turns out to be about 60.27, and they said to round to the nearest tenth of a foot. So I'll round it a little further and say 60.3 feet, and that would be what they're looking for. Oh, so you see how with the little bit we know from section 5.2, we know about the Pythagorean theorem, we know about the basic definitions for sine, cosine, and tangent, we know the angles in a triangle are 180, we're able to solve problems of this type. Okay, a lot of times you're the one trying to draw a picture, and that sometimes is the hardest part. Okay, there's one more part to section 5.8, and that deals with using bearings, and that's kind of a whole nother issue, so I'm going to do a different video for that.